Hello everyone. Okay, I would like to introduce myself. I'm Namrata, PhD student at IIT ISM Dhanbad. So this is a problem solving session, week 4 for the course Differential Equation for Engineering. In this session, we will discuss assignment 4 or you can say the problem related to assignment 4 which will helpful to solve your assignment. This assignment is based on week 4 session. Am I audible? Hello? Okay. What about our assignment mark? Niaz, your assignment marks, I don't have any idea about assignment marks or related to your assignment problems. I just wait. So these are the questions which we will discuss in this session. Please try to solve question number 1. Find the singular points and classify them for the equation. Please try to solve. And tell me the answer. What is singular point? How to classify? Please tell me. Have you learned about ordinary point, singular point, and type of singular point, regular, irregular? Have you learned these things? Okay. Okay. Question 1 is find the singular point and classify. For the equation, what is the equation? X cube x minus 2 y double derivative plus x cube y derivative plus 6y is equals to 0. How to solve? Okay. Give me the answer. What are singular points here?
X equals to 0 and x equals to 2.
Okay. This is the correct answer. These two are singular points for the given differential equation. For the given differential equation, isn't it? Okay. Now, if we rewrite differential equation in a standard form, okay, please try to solve and give me the answer. So, to write in this standard form, we can write equation 1 as x cube divided by x cube x minus 2. If we divide the equation 1 by the term x cube x minus 2, and we get the standard form, this equation. So this is the standard form. Now this is p of x, this is q of x. Okay, where x not equals to 0, x not equals to 2. Now how to classify? What should I do? What should we do? Tell me.
Needs to find the regular singular points.
Needs to find the regular singular. Regular or irregular? We have to calculate the limit of, for let's say for x is equals to 0, we have to calculate the limit to classify. Limit x tends to 0, x minus 0, or simply we can say x into p of x, x, these two will cancel. So this is finite, isn't it? Okay. Now similarly for x square, x minus 0 का whole square or simply x square q of x, we have to calculate this term. This will become in infinity, not defined or not finite. So what we can say from here? What we can say?
0 is not a regular singular point.
So it is irregular singular point. Yes. Ma'am, what is the motivation behind that we need to take the xpx and x square px? Uh, do you know what is ordinary points? Ordinary points at which px and qx are analytical, isn't it? Analytic. So all those points where px and qx will not analytic, those points will singular points, or you can say uh, the motivation behind it, you can say we have to check the limiting value near this point. For analyticity, we have to check the limit near the particular given points. For example, here we take x is equals to 0 to check px and qx both are analytic or not in the neighborhood of x is equals to 0. Are you getting? For avoiding negative powers, ma'am, in the polynomial. Okay. Niyaz, I don't know this answer. It can be true for avoiding negative power. Okay, I will check this point also. So this is irregular singular point. Now similarly we can check for x is equals to 2. So this gives 1, which is finite. And also what is qx? 6 upon x cube x minus 2. So this will become 0, which is again finite. Sorry. Yes, this is again finite. So from here we can say x is equals to 2 is regular singular point. When both limit will become finite, then we will say regular singular point, otherwise it will irregular singular point. Okay, is there any doubt in question number 1? All clear, ma'am. Okay, let's move to the next question, question number 2. Question number 2 is find the power series solution for the differential equation what is the equation y double derivative plus x y derivative plus 1 plus x square y equals to 0. Let's say question. So you have to calculate the power series solution for the given differential equation. First of all, tell me what is the point here, what is regular point here? Try to solve and give me the answer. First of all, tell me the regular points. What is the regular point in this differential equation? 0, I guess. Yes. Here 0 is regular point for equation 1. You can check it. Px, Qx, this is Px, this is Q of x. You can check limit. So clearly x is equals to 0 is a regular point. For equation.
Once, can you tell how to find the regular point?
How to find regular point? You have to check at which point the coefficient become vanish. In this case, at x is equals to 0, or you can also check singular point are those point at which coefficient is either undefined or discontinuous or multi-valued. So in this case you can see at x is equals to 0 the equation become vanish by first order derivative. Further you can classify it is singular or regular or irregular, but it is simply at those points where px qx are discontinuous or undefined, those points will become regular points, isn't it? Okay, now how to solve power series solution about x is equals to 0. Power series solution means we look for the solution of the form y of x is equals to summation cn x की power n varying from 0 to infinity. So first of all, calculate y derivative, y double derivative, and put these values in equation 1 and please try to calculate the coefficient. Please try to solve. Simply you have to put these values in equation 1.
Madam, y dash and y double dash, the summation n runs from 1 to infinity, and in the y double dash n is equal to 2 to infinity.
Yes, you can write 1 to infinity also, 2 to infinity, because at n 0 and 0, this term automatically will become 0 at n
Yeah.
0. And also second, at 0 and 1, at both points, y double derivative will become 0. So we can write 2 to 1 or 2 to infinity or 1 to infinity also.
Okay.
So let's put these values in equation number 1. Is it fine? Now, what should we do? Try to make the power of x की power n minus 2 n plus 2 all. Please try to make in the form of x की power n. So for this we should do n minus 2, replace n minus 2 with n for this first term, and for the last term we have to replace n plus 2 with n. You can use another symbol like m, and after putting you can replace m to n. Here I am taking power x to the power n minus 1. I am replacing n minus 2 with n, and in the last term I am replacing n plus 2 with n. So this will become n plus 2, n plus 1, cn plus 2, x की power n. You can also take here n varying from 2 to infinity, here 1 to infinity, because at 1 this term automatically becomes 0 at 0 and 1 both. I am taking 0 to infinity. Is it fine? Is there any problem in this step? After replacing this varying from n2 to infinity. Okay, in first and second term, we will put n is equals to 0 and 1, and rest of the things we can take common in single bracket. While putting 0 and 1, the terms we will get, you can check, these are simple calculations. Okay, after putting n is equals to 0, 1 in these two terms, we will get this equation. So, what's the problem with this? Okay. After equating the coefficient of constant term is equals to 0, similarly coefficient of x is equals to 0 and coefficient of x की power n is equals to 0, you will get C2 is equals to minus 1 by 2 C0, and similarly after equating this and this is equals to 0, we will get C3 minus 2 by 6 C1, and after equating this term n plus 2 n plus 1 Cn plus 2 plus is equals to 0, we can get Cn minus 2. Where n varying from 2, 3 and so on. So these are the value. We can calculate when n is equals to 2, then C4 will give 3C2 minus C0. Similarly, when n is 3, we will get C5. Sorry, this is n plus 2. Minus 4C3 minus C1 upon 3 into 2, 5 into 4, or 1 by 5 factorial into 4. We can put the value of C3, so we can get in the we can get the value in the form of C1. We can put here the value of C3, which is minus 1 by 3 C1. You can put here, you can get this term, or you can calculate. Is it fine? Is there any doubt? I guess there is no doubt. So we can put these values. Okay, we can put these values so that therefore the solution can be written as y of x c naught sorry, this is minus. You can put and you can check. This is the final answer. X की power 5 and so on. So this is the final answer. Is there any doubt? I guess there's no doubt. So move to the question number 3. Initial value problem. With initial condition y0 is equals to 4, y dash 0 is equals to 6. So what is the regular point here? Can anyone tell me what is the regular point for the given differential equation?
Zero.
Yes. 0 is the regular point. Why 0 is the regular point?
Since y of 0 and y dash of 0 is given, so x naught is 0 value.
Yes. So multi-valued are given at single point. So this is regular point. Isn't it? If at any point multi-valued will be given, then those points will become regular point. So here x is equals to 0 is a regular point. Okay. Again, we have to calculate power series solution. So we'll look for y of x is equals to summation cn x की power n. Again, we can find y derivative, y double derivative, and we can put and find, we can find the solution. Please put these values in equation 1 and find out the power series solution in the similar manner as we did in question number 2. Here is it multi-valued for y and y dash or multi-valued for y alone? Multi-valued for y or y derivative. In initial value problem, if there is given initial condition for y and y derivative, so this will call multi-valued for x is equals to 0, and for this reason this point will become a singular point. So yes, y and y derivative. Okay. Please put these values and calculate.
C0 is 4 and C1 is 6.
C0 is 4. Yes,
4.
it
The
is
C1
correct.
is 6.
It is correct answer. So we can easily calculate C0 and C1, but for C3, C4, or you can C2, C3, C4, we have to go through this calculations. Give me 1 minute. Hello sir. Good evening sir. Yes sir. Yes sir. सर हटा दिए थे मैंने आपको अच्छा yes. अच्छा हम आपको फोल्डर भेजे थे जिप करके उसमें नहीं हटा हुआ है ओके सर अच्छा ठीक है सर मैं फिर से उसको भेज दूँगी सर अभी मैं क्लास ले रही हूँ 5 बजे फ्री होके भेजूँ ऑनलाइन ले रही हूँ क्लास सर वही NPTEL सेशन डिफरेंशियल की चल रही है असाइनमेंट ठीक है sorry guys so please try to solve and give me the answer C0 C1 we can calculate with the help of initial condition since y0 is equals to 4 y of 0 is equals to 4 so C0 will become 4 y dash 0 is equals to 6 C1 will give 6 now we can put y derivative y double derivative in this equation. Let me write the equation. After putting y derivative, y double derivative, we will get this equation. Now multiplying we have to make this and this term in the form of x ki power n. So we can replace n minus 2 with n, and here n plus 2 with n. Is it okay? So after replacing, I am going to write after replacing, we will get this and this term. You can put n is equals to 0, n is equals to 1, then you will get the values. These are simple calculation, you can check, and if there is any doubt you can ask. And rest of the term we can write
C2 is 0 and C3 is 11 by 3.
what are you saying?
Constant C2 value is 0.
Yes, we can put C2 is equals to 0 and C1 is equals to 6.
And C3 is 11 by 3.
Yes, you're right. C3 will come 11 by 3, and similarly you can calculate C4, C5 and so on.
Yeah.
Yes. So after equating, you already know C2 is 0, C3 is 1 by 2, C1 plus C0 upon 6. You can equate this term from the coefficient of x with 0, then you will get this, and after equating this term with 0, you will get Cn plus 2 I'm going to write directly. Ran varying from 2 to 3, and C naught is given with the help of initial condition. C naught is 4, C1 is 6. So we can calculate C3. What is C3? 6 upon 2 plus 4 upon 6. So this will give 11 by 3. Similarly, C4, put here n is equals to 2, you will get C4. So this will give. Similarly, C5, you can check. Hence the solution is y of x is, you can put C naught, C1, C2, C3, then you can get power series solution finally. This is the final answer. Is there any doubt? Okay, move to the next question. Question number 4. Find the power series solution around. Find the power series solution around the point x naught is equals to 1 for the differential equation x square y double derivative plus xy derivative plus y is equals to 0. Please try to solve again. We have to calculate power series solution, but we have to calculate around x naught is equals to 1. How to solve in this case?
A regular point is 1.
Yes, regular point is 1. So x is equals to 1 is regular point. We can write we look for the solution of the form isn't it?
Yes.
Okay, so can you set t the place of x minus 1 and rewrite the differential equation in the form of t as independent variable? At the place of x minus 1, please put t and rewrite the differential equation. t plus 1 d2y by dt square plus t plus 1 d2y by dt plus y is equals to 0. Again, we can calculate y derivative, y double derivative. I guess you can calculate. I can write y value of y double derivative in this equation directly. Is it fine? Are you getting this step? Simply replace x minus 1 is with t. So at the place of x we can write t plus 1 whole square, and this will become d2y by dt square. At the place of x again t plus 1 and rest of the thing. Is there any doubt in this step? Tell me if there is any doubt. Can we replace x minus 1 with t?
Okay, ma'am.
Okay. So from here you can simply calculate and you can equate the coefficient, then you can get the answer. Try to calculate. This is for first term n minus 1. I'm just multiplying this term with this series. So you will get these three terms after multiplying. Now I'm going to multiply second t plus 1 with the series. So we will get after multiplying with 1 we will get this is n minus 1 and similarly we can replace this. In this we can replace n minus 2 with n. In this term we can replace n minus 1 with n, and in this term also you can take these two terms together. After replacing I'm going to write this second term. So this will give n plus 2, n plus 1, cn plus 2 t power n, and this two term after replacing this term 2n n plus 1, and this will give n plus 1 n plus 1 cn plus 1. Sorry, here there is a term cn. Cn. Okay. N square minus n. This is first term, n square minus n plus rest of the terms. Is it fine? So here in this step, simply replace n minus 2 is with n, and here, okay, so this will become this, and this and this term written here, and rest of the term c of n written here. Is it okay? You can check this. This is simple calculation. Now we have to equate the coefficient. For n is equals to 0, put n is equals to 0. Here, after putting n 0, you will get C2. Here, this term will 0, and this term from here we will get from here we also get one term. After putting 0, we will get C1, and here from here we will put after putting n is equals to 0, we will get C1. So I am going to write C2. You can check, and after putting n is equals to 1, you can check, we will get. These are simple calculations. Simply put values of C3 and C2 in the form of C0 and C1, then you will get plus C0. You can check. These are just simple calculations. Okay. Therefore, the general solution we can write y of x C0. At the place of t, we replace, or we can give back substitution. So we will get x minus 1 whole square plus 1 by 2 x minus 1 whole cube minus 5 by 12 x minus 1 4 and so on. Similarly, so this is the answer. Is there any doubt?
No, ma'am.
Okay, let's move to the next question. Question number 5. Question is, find a polynomial approximation of fourth degree to the solution of the equation. What is the equation? In this question, we have to find a polynomial which approximate the fourth degree of the solution. Question is clear? In this case, x is 0, x is equals to 0 is a regular point for the given differential equation. So, a power series solution exists in the neighborhood of x is equals to 0. Can we suppose y of x approximate fourth order polynomial? So here can we take 4 according to the question? Then by initial condition, C0 we can get 0 and C1 we will get 1. Now we can substitute y derivative, y double derivative. So this is y. C3x cube C4x की power 4. You can calculate y derivative. So sorry, this is C0. What is C0? Y derivative. It is C1 2C2x plus 3C3 x square plus 4x cube. Similarly, y double derivative 2C2 plus 6C3 x. Now we have to put these values and we can equate the coefficient of x की power n and we can find out the values of C0, C1, C2. C0, C1 already find out. So after putting this is 6 and C1 plus 2C2x and what is the value of y of x? C0 plus C1x plus C2 x square plus C3 x cube plus C4 x की power 4 equals to 0. By equating the coefficient of x की power n first of all we can equate constant term, then coefficient of x square. I'm going to write the equation after equating. Because C1 is 1, C0 is 0, C1 is 1. You can put, then you can get C2. And second, after equating the coefficient of x, you will get, you can check it. After putting C0, C1, C2, you will get value of C3. You can check it. After equating x square, coefficient of x square, you will get so from here you will get the value of C4. Now the fourth degree polynomial, the fourth polynomial approximation you can say. Therefore, because C0 is 0, C1 is 1, C2 is 1 by 2, C3 is 1 by 3, 5 by 24 x की power 4. So this is the answer. Is that clear? Tell me if there is any doubt. Is it clear? In this question, we have to approximate the solution to the fourth order degree polynomial. So we can take yx n varying from 0 to 4 cn x की power n, and with the help of initial condition we can calculate C0 and C1, and also we can write yx as y dash, y double dash, and we can put, after equating the coefficient we can get the coefficient value C0, C1, C2. Is that clear? Okay, next question you will do. Similar question. Question number 6 is, I am going to write the question. Find the polynomial approximation of fourth degree to the solution of the equation. The equation is y double derivative, xy derivative, you can solve in similar manner as we did in question number 5. Please try to solve. You have to take the polynomial, fourth degree polynomial. Please try to solve and give me the answer. Because this is similar question as we did in question number 5. The solution is similar. So here x is equals to 0 is a regular point. Since x is equals to 0 is a regular point, so power series solution exists in the neighborhood of x is equals to 0. So suppose since we have to approximate fourth order, so we can take n is equals to 0 varying from 0 to 4, that is fourth degree polynomial. My initial condition C naught will give -1, C1 will give 0 from here. Now by substituting yx and y dash x, y double dash, we will get, so I'm going to write y double dash as we have calculated y double dash, y of x, we can directly put from here also. I'm going to write the value of y double derivative and x multiplied by y single derivative plus 3c3x square plus 4c4x cube plus 1 plus x c0 plus c1x c2x square c3x cube plus c4x की power 4. Now please equate the coefficient of x की power n and find the values of coefficient. We have already c0 and c1. So I'm going to equate constant term. This will give, so from here c2, because c0 is -1, so c2 become 1 by 2. After equating x, coefficient of x, you will get, so after putting c0 and c1, you will get c3. After putting you can calculate, these are simple calculations. So here the value of c2, c3, c4, therefore the fourth degree polynomial, which is the approximate solution for the power series solution of the given differential equation. minus 1 plus x square by 2 plus x cube by 6 minus x power 4 by 8. Is there any doubt in this question? Please tell me, is there any doubt? Is there any doubt in this question? Question is, find the polynomial approximation of fourth degree to the solution of the given equation. I think there is no doubt. Okay, let's move to the next question, question number 7. Express the polynomial x cube and x cube plus 2x square minus 3x plus 6 in terms of Legendre polynomial. How to solve this question? Can anyone solve this question? Have we learned about Roderick formula? Pn x is 1 upon 2 की power n factorial. So this is Roderick formula for Legendre polynomials. Now you can easily calculate by putting n is equals to 0, 1, 2, 3. You can calculate. So when n is equals to 0, you will get p naught x. So this will become 1. After putting n is equals to 1, you will get p1. You can differentiate. So this will become x. Similarly, for n is equals to 2, we can calculate p2. So you can expand this term and you can differentiate 2 times. After differentiating, you will get, please check this, is this correct or not. Similarly, for n is equals to 3, we can get P3. So we have to find the polynomial xq in terms of Legendre polynomial. Can we get xq from here in the form of Legendre polynomial? At the place of x, you have to put p1x, and you can replace the constant coefficient with p1x. Sorry, p0x. So you can easily get the value of xq in the form of Legendre polynomial. Now we have to find this polynomial in the form in terms of Legendre polynomial. We have to calculate xq plus 2x square minus 3x plus 6. So what is xq? From here you can put xq. What is x square? 2 into, you can find x square from here. You will get 2p2 plus 1 upon 3. So 2p2 plus 1, you can write 1 at the place of 1, you can write p naught x, 1 upon 3, and also minus 3x, x is p1x, and 6 into p naught x. So after simplifying, you will get so this is the answer. Is there any doubt? Please let me know if there is any doubt in this question. Is that clear? Give me the answer. If clear, you can say. Okay. Now let's move to the next question, question number 8. Use first recurrence relation for Legendre polynomial to show that you have to show P100 of L, P502 of L divided by less than 0 if 501 sorry P of 501 of L is 0. So you have to show P 500 of L upon P 502 of L is finite or less than 0. Less than 0, not finite. If P of 501 of L is 0. What is recurrence relation for Legendre polynomial? Okay, is given by n plus 1 En plus 1 of x so this is recurrence relation for Legendre polynomial. Is it okay? Now put x is equals to L and at the place of n please put 501. Sorry, this is 501. Then the relation become this will become 1003 L P of 501 of L minus 501 P of 500 L. We have to provide it. We have 501 of L is 0. So this will become 0. You can get which is less than 0. Is it okay? Shall we move to the next question? Okay. Question number 9. Again, use first recurrence relation for Legendre polynomial to show that please try to solve it. Have you done Legendre polynomial? Please try to solve this. Use orthogonal relationship and what is orthogonality relation of Pn and use first order recurrence relation, integrate from -1 to 1. You can easily get tell me the orthogonality relation. Yes, Niyaz?
Is it integral minus 1 to 1 Pn of x into Pm of x?
Yes, what is the value of this integration?
And that is 0 if m not equal to n, and
Yes,
2 upon n, 2 upon n plus 1 if m equals to n. Sorry, 2n plus 1.
yes, correct.
Okay.
So this is the orthogonality relation. This is the correct answer. First, we know that Legendre polynomial satisfy that is, as Niyaz says, Pnx, Pmx 0 when m is not equals to n, and 2 upon 2n plus 1 when m is equals to n. So this is the orthogonality relation. So we have first recurrence relation. What is it? N plus 1 Pn plus 1 of x equals to 2n plus 1 x Pnx minus n Pn minus 1x. So we can multiply, we have to show this integral. So can we multiply this recurrence relation by Pn minus 1 so that we can get this term? After multiplying Pn minus 1, we can get this term. So let's do it by multiplying with Pn minus 1x in the recurrence relation in above equation and integrating over minus 1 to 1, we will get simply you have to multiply with Pn minus 1 in the recurrence relation and integrating over minus 1 to 1. Now we can use orthogonality condition. So because here if we consider m and this is n, both are not equal, so that this term will become 0, and we can write of x sorry can you calculate the integral of minus 1 to n Pn minus 1 square with the help of orthogonality relation. Simply you have to put n minus 1 n minus 1 here. Both are n minus 1. So you will get 2 upon, at the place of n you have to put n minus 1. Two here, n is all, there is already n, 2n plus 1 from here and 2n minus 1. Is this okay? Is there any doubt? Is it fine? Okay. Let's move to the next question. Question number 10. This is the last question. Again, use first recurrence relation for legendary polynomial. To find value of minus 1 to n x square pn square of x dx. So you have to calculate the integral minus 1 to n x square pn square x dx. And you can use recurrence formula, recurrence relation for legendary polynomial. Please write the recurrence relation and how to find. Can anyone tell me after writing recurrence relation? Okay, let me write the recurrence relation. Give me the idea. What, how to solve? How to find this integral? I'm waiting for the answer. We divide 2n plus 1. Right hand side. We can divide also and squaring both. Yes. We can square so that we will get x square pn x. Here the motto is we have to calculate this term x square pn square. So we have to square this recurrence relation so that we can get x square pn x square. After squaring, 2n n plus 1 pn plus 1 x Pn minus 1x plus n square Pn minus 1x. Now you can divide 2n plus 1 square and you can integrate over minus 1 to 1. How to find the value of Pn plus 1 square? Integration over minus 1 to 1 Pn plus 1 square how to find the integral value. So we have to calculate this and this term. Again, can we use orthogonality relation? So orthogonality relation is minus 1 to n Pnx Pmx dx is 0 when m not equals to n and 2 to n plus 1 when m is equals to n. So if we put n and m both n plus 1, because we have to calculate this term, so you have to put here n plus 1. Is it okay? And similarly Pn minus 1 square 2 upon 2n minus 1 plus 1, this will give 2n minus 1, and this will become 0 because these are not equal. With orthogonality relation we can say this term will become 0. Now we can put here and here the value of Pn plus 1 square and Pn minus 1 square. So we will get n plus 1 square 2 n plus 3 plus 0. The second term will become 0 using orthogonality relation. This is minus 1. Or minus 1 to x square Pn square dx. We can take 2 outside. Is there any confusion? Dr. Swami HS joining now. I think this is last question. Here we have the term 2n plus 1 square. So we can divide by 2n plus 1 square. So this is the answer. Now tell me, is there any doubt in this question? Question number 10. In this question, we have to calculate the integral. So by using recurrence relation, we can find out. Just squaring both sides and integrating over -1 to 1, and using orthogonality relation, we can evaluate the integral terms like Pn plus 1 square, Pn minus 1 square, and Pn plus 1, Pn minus 1, so that we can find the integral -1 to n x square Pn square x. Is that clear? Okay, that's all from my side. If you have any doubt, any queries, you can ask. Yes, Niyaz? I didn't get the assignment score yet for all the 3 assignments submitted. Sorry, Niyaz. I have no idea about your assignments problem. You can mail NPTEL, you can ask regarding these queries. Lakshmi Arya, you can mail Padma Priya. Yes.